Welcome to our second video. We're going to be talking about now this idea of the process improvement definition of quality. And this orientation is going to focus on interpreting the flow of work in processes. So what we see is that any process could be actually understood as a five-step process. When we want to investigate it, we first have to map it. In other words, understand what is a physical flow, what does it look like? And then we have to measure it because we need to understand how well is it operating. And then we have to mine the data that we've collected about it to find how those measurements tell us about how good it's working or where it needs to be improved. And then after we understand that, we need to work on modifying what is the improvement we need to have. And once we've made the modification and demonstrated that it works, then we go into the maintenance mode. And this is where we maintain or sustain the performance of that improved process. So this is achieving the new level of process performance. Underneath this is a four-step process, basically, that we call process thinking. So the first is that we have to understand the components of work and how the work actually flows. Then we have to identify critical process measures and the performance levels that are necessary for the process to be operating efficiently, effectively, and economically. Third, we have to discover the sources of variation both within each activity and between the activities. It's not enough to understand individually the activities, but we have to understand what happens between them. In a diagram, this is like looking at the arrow between two boxes. So we have a box, something's happening in there. We have another box, something's happening there. But what is happening on the arrow? It's some sort of transportation system or movement indicator. And finally, we have to seek solutions that minimize variation for the critical metrics that we have. So the process, we have some discussion questions here. So what is good flow and process behavior? Why is that important? Well, that's one of the interesting things. If we have good flow, we have a healthier system. So what is a process? How is it constructed? And how is your process flowing? Well, let's take a look at these questions. So why is good flow important? So here we see two different types of systems. We see a river system. I think that's the Yangtze River in China. And what we see is it's flowing from the little brooks and tributaries into the branches and then into the main river and finally into the ocean. That's an outward flow. It's a one-directional flow of the process. If we take a look at human lungs, we see that there's a two-way flow. An input flow and an output flow. So in goes the good air, out goes the bad air. And so what we see is in each of those, flow is manipulating something that is a content. The better something flows, the healthier it is. If we think of a body, we think heart flow. If we have a good steady heartbeat and it's strong, then we say we're healthy. If our lungs are operating effectively and they carry in good air and take out bad air, they're operating effectively. If our digestive system is working smoothly, but any of the upsets can cause lots of problems. So we have pulmonary problems, cardiology problems, gastrointestinal problems, and we're no longer healthy. So the same type of logic applies to organizations. When our processes do not flow properly, they're not healthy, and they require some sort of diagnostic attention and remediation. That process of diagnostic attention and remediation we call continual improvement. So just like we have to exercise to keep our bodies in good shape, we have to do exercise and watch our diet also in terms of how our process is operating. So what is a process? Well, basically the fundamental definition is all work is accomplished using an interconnected system of work processes. So some examples of processes might be designing a product or ordering parts or actually making a product in the production environment, shipping it to the customer, billing the customer. All of these are individual types of processes. Now they're very different. Some might be a design process done in computers, some might be done in the physical world, some might be done logistically, if you will, through third parties. So each of those, though, is a process. And all of these may have sub-processes depending on the complexity and completeness of the system that we're looking at. Now, if we take a look, what does a process tell you? How well does it work? Well, the way we understand a process at the very highest level is we take a look at the inputs we get from suppliers to the process, the set of process activities that process the flow to get the output that's delivered to customers. Now, if we take a look at this and the customer is rejecting the output, in a legacy system, what we tend to do is get into excuse making and negotiated settlements, or perhaps paying reparations to customers even, or paying penalties. And so we start seeing that's not actually a good way to assure quality because the customer had the bad experience. We didn't stop that from happening. If we take a look at the input side and we see we don't have good situations there, then we start getting into blame casting. Let's blame the suppliers. What workers didn't do it, which factories, what materials were wrong. And then we start looking at getting defect reparations. So again, here we're looking at shifting liability to the suppliers. And as we start seeing, this is all legacy thinking. This is no longer acceptable when we have a strong quality component in the way we have built our business system. So there are 4 rules of process performance that we want to apply. First is that all work is accomplished in an interconnected system of work processes. And that means that we can visualize those connectivities, understand them, measure them, and analyze them. Performance varies over time, and this variance may be measured. So we can see the difference in performance as the inputs change, or the materials change, or the information or the people change. Third, we see that the sources of process variation are discoverable through analysis methods. This is why we use statistics and probability theory to understand what's happening at the more complex level. At a simple level, we can just see the differences when we see people performing differently within the process. And finally, if we reduce variation, we can improve the processes so they become stable and predictable. And stable and predictable processes basically come from 2 things. One, we have standard work people are performing consistently. And the second is our measurement system indicates that there is no unwanted variation happening from externalities to our process. So if we look at this process and we define it, we see it's a series of tasks, activities, decisions that coordinate the work of people to produce an outcome that meets a specified need. And that specified need is a customer requirement. So we activate a process when there's a request to do something, a customer order. This triggers the activities to produce the outcomes and bring together all the inputs necessary to drive that quality output. Measurements are taken at checkpoints in the process so we can evaluate how well we're doing. And then at control points, we can manage the flow of the process to speed it up or slow it down. And then we have feedback loops that we use to activate corrective actions to make sure we stay on targets and reduce the variation that may happen to wander into the process from unknown sources. So this is basically how that process is operating. So this process is a series of things. Now it's got a command or a signal that starts. The inputs are information, materials, or supplies. The outputs are information, products, services, or deliverables. And it uses resources like equipment or competence of people or financial resources to accomplish its work. So each of those are fundamental elements of how we define that process. And as George Box, a statistician, said, different processes are afflicted by different diseases. So if we see production as a process, that process may be different from one product type to another. The chemical industry is somewhat similar, but different from the pharmaceutical industry, which is similar, but somewhat different from the petroleum refinery. And that's very different from machinery or from making mechanical equipment. So as we start seeing every different process will have different types of inputs, outputs, and requirements. And we have to evaluate them in the context of the work that's being accomplished. So when we observe this, we see these differences in what we call rational subgroups. So rational subgroups are the logical way we can decompose these different types of flows into the process. So we might have different rational subgroups around orders coming in. So maybe they're customer orders, or maybe they are coming from another factory in our own business. Maybe it's a service order for parts that are necessary. So we have these command signals, we have the inputs, And we see that's beginning with the bill of materials. That goes all the way back to the suppliers and the orders for parts to suppliers. And the outputs include not only the product itself, but also how much labor we put in, how much cost we embedded into it, and even the IT data that's used to report the status of that flow through the line. And the resources we can use to understand what was happening on the build plan. Did we build to the resources? And how good our order forecast accuracy was when we're actually taking a look at what we perform versus what we thought we should be performing given the expected orders from the market. And so when we start taking a look at this, we see inside our process that there might be these triangles here which are called process checkpoints. So these are places where we check the flow of the process. Do we have everything necessary at the beginning of the process to begin production? When we get to the middle of the process, how well are we doing in terms of the flow of this activity? Have we actually achieved everything we need to at the time we go into intermediate test? And then maybe a process control point. And here we're going to be measuring something from the output to see what's the quality level, what's the delivery performance expectation? Will we be on time? And do we need to speed up the process, slow down the process, or rework the process because something's not operating right? So control points manage process throughput flow, and they establish stability in the quality of the process output. So basically, process flow all the way through needs to be a measurable and traceable event, and our measurement system has to be linked so that the input measures, the process measures, and the output measures all have a known relationship to each other, and that system can be predictive of the final results that we will deliver to customers. So when we take a look at this, we see that there's really different perspectives we can take when looking at the process. So if I take a look at the external customer perspective, they see what we would call the end-to-end point of view. So they see all of our process. So if I say our process is these 3 different steps, they see from cycle time A beginning to cycle time C completion. And they would see that as the lead time from their order to the delivery of the product or service they have ordered. An internal point of view says we would see our process owners looking at just their process. And they have a different way of optimizing performance or looking at it. So they are focused on the cycle time. And that is the beginning of their process step to the end of it and the turnover to the next step in the process. And so what we can see is that these process steps will tend to be well managed within the process owner's cycle time. But there is an opportunity for some sort of problem occurring at the handoff between the local process owners. Do we have good coordination across the processes as well as sound management within the processes? So how does a process really flow? Well, if we take a look at a process map, we get some sort of view of the efficiency, effectiveness, and economy of the process. And we have some sort of understanding of what it is. And then we say, well, wait a minute, if we look at it and we do what's called a Gemba walk, we go and actually see what's really happening, we might see it's actually something different. There's some checks we forgot about, and there's an occasional rework cycle and so forth. And we see that there's more complexity in the process than we thought about when we were just doing our first mental imaging of the process. But the trouble is, what we really want it to be is something even more streamlined. And we don't want to have so many checkpoints. We don't want to have so many backwards flows and rework. And so the possibility is going to depend on who does what and when they do it and how well it's done. And can we reduce cycle time? Can we increase productivity or effectiveness? Can we reduce the cost in each of the steps in the process? So the best way is to have one best way of working. And that's called a standardized way of working. And this is what we're going to be building up in our daily management system. How do we have a standard for how we deal with these things? So what I want you to do as a team is to think about what we've talked about here. And first of all, begin by listing the most important processes for your team. What are those sub-processes that you're working on a routine basis? Then select one process and ask, how does it flow? Are there delays or waiting time in the process? Where is the beginning? Where is the middle? Where is the end? And what's happening at each of these? Where can we measure interim progress? And where can we monitor quality issues to see what's occurring? And then where and how can process performance be controlled? What can we do to make our process flow more smoothly and to produce more quality results? So enjoy this first investigation of your process performance.